Hey,
Hey, how are you?
good. How are you?
Good.
Okay, do I have you on as the host
Yeah.
now?
Yep. And Miss Rahman, when she comes in, I'll make her a co-host.
Okay, perfect. How's everything going?
Good, good.
Good.
I've calmed down a little bit since what?
Your math video is public now on YouTube. You're a
Oh
star.
gosh. Oh, great.
No. It's really cool. It's really cool to see.
Yeah.
Yeah.
It'll just get better.
Yeah, exactly.
Today
Okay.
should be fun in science because I actually have like a demo for them, and so they would have at least tried to make these electromagnets. I don't know if you could really
Yeah,
see.
I could
But
see. Yeah.
I've made a few of them with like different coils of different amounts of coils, and so the property that we're testing is how the number of coils affects the strength of the magnet.
Okay.
So I've
Okay.
got like iron filing set up underneath the camera and everything like that, and we'll be able to. Yeah.
Ooh, fun. What's up with Veron? Why can't we see her? Hi, Miss
Good
Ramon.
one.
No, I covered my video for a second.
Oh, okay. When they're in the waiting room, are they just by themselves?
No, that just means that they have to just be accepted into the thing.
Right, they're just waiting for us to accept
They're
them.
just waiting for like
There's no actual, they're not chatting with each other.
no.
Bailey was here, then she left.
Maybe because she saw nobody except for like you two.
Aw. Okay, I'm gonna pop on out of here. I'm gonna go see sixth grade. I'll be back, okay?
All right, thank you.
Yep.
I think like the only person would probably be missing is Daniel for today. Tinty still cannot like get to him or his family, so I'm gonna try again, and then I think when we all come back at like what time, 3:45, we were gonna talk about
Yeah.
it.
What I'm gonna try to do is, because in my math class, we had them all muted like pretty much the whole time, and I think like we tried to like disable the chat,
Uh-huh.
but like I want to kind of like enable some group discussion. So I actually want to like allow them to respond in the chat to like brainstorm ideas. So hopefully they'll use it appropriately, and if they start chatting things that's off topic, then we'll have to.
Yeah, I'll have like the chat open the whole time and look at that.
This is stressful.
Yeah, I know. There's just so many things to look out for in the middle of teaching.
Mm-hmm. I wonder if they're leaving because there were 7 people in the waiting room and now there's only 5.
Let me yell at my advisory group.
I want to start. Should we start letting them in?
Yeah. Hello. Enter the class, please. Awesome. Now I'll start renaming. Who is this? Mr. M103.
That's
That's
Vicky.
Vicky? Okay. Mrs. Oh no. Let's see. Participants.
All right. Does everybody? I'm probably gonna ask this again in like a minute anyway. But does everyone in the room right now have a science packet? Okay. This means no, Chanel? You're doing the no sign? Okay. So Chanel, anyone that doesn't have it, I'm gonna do kind of like what Miss Ramon did in the last lesson. I'm gonna have the Word file open, and you can follow along and take notes on a piece of paper. I mean, really anything that you need to like read, you could just read off the screen.
Okay.
But you can also follow along with the PowerPoints. I'm gonna put the PowerPoints up.
Miss Amador, could you make me the co-host, please?
Oh yeah. Manage participants. Oh, admit Jason, admit Bailey.
Vicky, you had an hour lunch break and you're eating your lunch now.
Also, you're sideways. Your phone or tablet or something is on its side. Okay, so it's 11:50. I'm gonna get started right now. So the first thing that we're gonna do is we're gonna get into a review. But before we get into the review, let's just chat. So in the chat, the question that I'm asking to everyone is, what is an independent variable? So you can just type in the chat to everyone what you think an independent variable is, your definition of an independent variable. And I missed a question mark there. That should be a question.
Mr. Everett, do you want them to respond to the group chat?
Yep, thank you, Chanel.
Great.
An independent variable is a variable that is changed in the experiment. Yeah. What else we got? What other ways of thinking about an independent variable? A variable that can stand on their own. Yeah, so it doesn't depend on the other factors. So it stands on its own. That's a good way to put it. Jessica, your video is sideways. Let's get one more in the chat. Let's see. It is that changes. We got from Leilani, a variable that doesn't change and isn't dependent on others. Carlo, it is something that doesn't rely on other things. Okay. So yeah, the idea that it doesn't rely on the other variable. The independent variable is the one that you want to change in the experiment. So that brings us to the dependent variable. So what is a dependent variable? Question mark to the chat. Let's get something from Kaylin. And let's get something from Jessica and Jalen. If you'd prefer me to unmute you, a variable that needs other things. Okay, Carlos says something that is relies. So something that relies on other things. What do you think, Kaylin? I'm gonna unmute you.
A variable is something that like it changes, like it can be affected by like the other things.
Yeah, exactly. So thank you everybody for your participation. Your independent variable is the thing that you change, and the dependent variable is the thing that you think is going to be affected by it. So for example, maybe you might think that the higher you drop something, the faster it will be when it hits the ground. So your independent variable is how high you decide to drop it. And your dependent variable would be how fast it is when it hits the ground. I'm going to screen share the review with all of you. So now that we've done a quick review of independent and dependent variables, I'm going to screen share the review. Anyone who has their packets, just go ahead and start looking and working on the review. And I'm about to screen share for those who need it. Give me thumbs up if you are seeing the review on the screen share. Okay. Let's take maybe about 3 minutes or so to do questions 1 and 2 in the review, and then we'll move on to question 3. I'll scroll down for those who need it. Caitlin, we lost your video.
Hello.
Vicky, we can't see you.
Jason, take off your hood, please. Thank you.
Let's see if I can write on the screen.
If you take out your stylus, it helps.
So just a reminder that independent is what you change. And the dependent is affected by that change. So the dependent is affected by the change in the independent variable. In about 30 seconds, I'm going to scroll down so that we can move on to 3 in the review. Actually, what I'll do is let's go over 1 and 2 first, and then we'll do 3. All right, I want everyone to get ready to type into the chat their answers. So let's go over number 1. The number of nails in the core is the, type the letter of the answer that you think it is. I'm going to stop the share just so that I can see the chat better.
We can't see the review.
I just removed it so that I could see the chat better. Do you have the review in your packet, Carla?
No.
No? All right. Let me go back to the screen share. Okay. All right, let's do numbers. 1 is A, 2 is B, 3 is C, and 4 is D. For number 1, what do we think? What letter? Show me in your hands. 1, 2, 3, or 4.
A.
I see 1. I see 1. Yep, number 1 is A. So the number of nails in the core is the independent variable. That's what these students are changing. Let's go to number 2. The number of paper clips the electromagnet picks up. Is it 1, the independent variable, 2, the dependent variable, 3, the control group, or 4, their hypothesis? Let's see those fingers. Leilani, I can't see your fingers. Oh, I can see now. Okay. Morris, if you're going to do 2, just spread them like so I can see that they're 2 and not 1. Yep, thanks. Yeah, this Bailey, what do you think? 2. This is the dependent variable because this depends on how many nails are in the core. And guess what? We're not going to get to it just yet. We're going to get to it in a few minutes, but I've actually made electromagnets. And I'm going to put them in the, I'm going to put them under the dot can, and we're going to do a little bit of an experiment today. So let's go on to number 3. I'm going to scroll down to numbers 3 and 4 in the review. So take the next 3 minutes to answers number 3. Actually, I may need to zoom out just so that you can still see the text and be able to answer number 4. Can everyone see that even though it's really tiny? Give me a thumbs up if you could see, if you can read everything. Okay, cool. Carlo, please come join us. Okay, so Kaylin, what you can do right now is you can follow along with, I'm gonna put the stuff up on the screen. We'll send you the packet. So we can send you the packet, send you a link to it or in the file, and you could, if you're able to, print it out at home. But for now, just follow along and write any notes down on a piece of paper or in a notebook. Jason's got your hand up. I'm coming to you, Jason. Jason, you're unmuted.
Oh, yeah. Can I get my pencil? Because I lost my pencil.
Go ahead.
Can I get
Go
a new
ahead.
one?
Mm-hmm. All right, we're gonna take, how many more minutes do we need to finish 3 and 4? I'm thinking about 1 minute. Show me 1 if we're good for 1 more minute. Some need a little bit more. Okay, I'll check back in 1 minute. All the information that you need for 3 and 4 are in this paragraph about what they did in the experiment.
Vicky, you there? Hello, Vicky?
Can I erase this too now? Yeah. Someone needs to mute themselves. All right, we're gonna, because I want us to have as much time going through the actual experiment as possible today. Let's go ahead and review these. Give me a thumbs up if you want to share out your answer for number 3. Thumbs up, or actually raise your hand. Let's practice using the raise hands, because it's going to be easier for us to see the raise hands button. Great, thank you, Chanel. Chanel's got her hand raised. All right, Chanel, I'm unmuting you. Can you give us your answer to 3?
For number 3, the answer is increase and decrease.
Okay, so Chanel says that based on the results of this experiment, as the number of nails in the core of an electromagnet increased, so Chanel says increase, the strength decreases. Do we agree or disagree with Chanel? Show me in your hands, agree or disagree? I'm gonna go to Jessica. Jessica, you changed your mind from disagree to agree. Let's go to Jessica. Okay, go ahead, Jessica.
Yeah, I did. I changed my answer from increase to decrease.
What do you mean by that? There are two fill in the blanks here. So do you agree that that as we increase the number of nails, that the strength decreases?
Yes.
Okay, where's the evidence from the experimentation that suggests that? I want everyone to look into the paragraph, and let's go ahead. I'm gonna model this together now. So,
Mr. Amador,
Yeah.
if you could just raise your voice. I'm not sure if they can all hear you.
Okay.
Thank you.
How's that now? Is that better? Give me a thumbs up, everyone, if my voice is loud enough. All right. So on their first trial, they found that the magnet picked up 4 paper clips. So the first trial had how many nails? Didn't it have 5? So 5 nails in the core, 5 nails core equaled 4 paper clips. Anyone disagree with what Jessica and I think Morris disagreed, right? Morris, so now that I started us off, can you finish my train of thought here?
Well, if you see the more, like, I think the more nails in the core of the electromagnet, the strength of the magnet increases, because if you look at the text, it says that, like, for 3 nails, then it was, if for 3 nails, it was only 2 paper clips that it could pick up. And so, like, if you compare it to what Mr. Amador wrote on the screen, then you can see that as you increase the nail, like the nails used in the core, the number of paper clips you can also pick up increases.
Exactly. So you can either write this as the number of nails in the core increases, the strength of the electromagnet also increases. More nails in the core means a stronger magnet. The other way that you could write this is you could write this as the number of nails in the core decreases, the strength of the electromagnet also decreases. So there's 2 ways of writing the same thing, because they
Galen,
move together.
come back to class.
As one goes up, the other goes up. As one goes down, the other goes down. And we could see that when we actually fill out this table here. So the number of nails in the core for 1, we had, I think, they picked up only 1 paper clip. For 3, it picked up 2 paper clips. For 5, it picked up 4 paper clips. Show me on your hands what you think is a reasonable prediction of how many paper clips 7 cores, a 7-nail core could pick up. Show me on your hands. What's a reasonable prediction? Give me a thumbs up if you understand the question. So we're looking at number 4 here. And if we increase the number of nails in the core to 7, how many paper clips do we predict? Jason's hand is up. I'm unmuting you.
No, I was asking you if you can say the question again, but you're already saying it.
Okay.
So
Someone give me a prediction. Come on, let's go. Let's get on to this experiment here. I see Bailey's giving up the number 5. Yeah, I think 5 is reasonable. Maybe 6, but more than 4, right? So maybe 5 or more. Because as we increase the number of nails in the core, we would expect the strength to also increase. All right. So what we're going to do today, let's turn to the next page in your Scholar packets. We're actually going to do an investigation for the strength of an electromagnet. So what I want us to do is let's chat, let's text out some brainstorming ideas of what an independent variable that we could test. So we want to test the strength of an electromagnet. What could we change to maybe make it stronger? You can send it in the chat, or if you raise your hand, I'll unmute you. I see Vicky's got was that a hand raised? I'm trying to, I don't even see an audio for Vicky. All right, so in the chat, we've got Chanel, to answer you, we're just doing this together, okay? So I'm gonna give you a demonstration, and we're gonna write down the independent and dependent variables together. And I'm actually gonna do the experiment under the camera. and we're going to record the data together. Good question. The amount of what? Amount, Carlo, amount doesn't mean anything. The size of the core, potentially, Bailey, that could be an independent variable. The amount of nails what? The amount of nails there are, where? So the amount of nails doesn't really, the amount of nails that I built my house with, the amount of nails what? The amount of nails in the core, exactly, Tansel. So that is the same independent variable that we used in the, that we read in the review. What's another independent variable other than the size? Yep, the amount of coil wrapped around the core, Bailey, the amount of nails in the core. Yeah, so the one that I've actually prepared for today is the number of wraps, the number of times that the core is wrapped with wire. Because you may remember that the more number of turns, the more number of turns that there are, the stronger we think that the electromagnet will be. But let's actually test that today. So our independent variable is going to be the number of turns of magnet wire around the core. Everyone should be filling in your independent variable, the number of turns or coils. If you don't have a packet, you're just writing it down, that your independent variable is the number of turns of wire. What can we test? So how can we test the strength? If we want to know if it gets any stronger. How can we test that? Let's go to, let's see. Let's go to Leilani. Okay. So we want to test, I unmuted you. We want to test how strong our electromagnet is. How can we test that? What might our dependent variable be?
What it can attract.
What it can attract. So basically, like how much stuff it could pick up. So yeah, that's a great idea. And what I've actually prepared for today is I have iron filings. So I have a dish of iron filings, and I have a way to weigh how much it actually picks up. So the dependent variable can be the mass of iron filings it picks up. Mass of iron filings picked up. Morris, you got a question? You can unmute yourself.
No.
If not, then I'll unmute you. Where's Morris? Morris, we also lost your video. What's your question?
Oh. My question, so what does the first thing say? Like,
oh, this is number. This is number. Yeah, I'm pretty sloppy at writing on this thing. I'm trying to get better at it. This is the number.
All the way up. All the way up. You should not be laying on your stomach. Let's go. Sit up.
This is the number of turns of wire.
Tanzel.
So basically, if you think about it, the core is a nail, and then basically how many times we turn, how many times we wrap a wire around it. It's the number of turns.
Thank you.
The dependent variable is going to be how much iron filings we can pick up. Control group. We need to keep some things the same. Because if we don't keep them the same, we won't know for sure if it's really our independent variable that's making a difference or not. So one thing that we should keep the same is the current. Oh, those are control variables, but the control group is going to be something that we don't wrap at all. So this would be a nail with no turns of wire. So we'll test the nail with no turns of wire. What other variables do we need to account for? Sir, do we have, oh, okay. What other variables do we need to account for? What are some things, chat out, let's go, chat out some ideas. What should we keep the same if possible? Morris, go ahead. You got a hand up.
So
Anyone else could just chat out too right now in the chat.
things you need to keep, like things you need to account for is like things you need to account for. I think it would be like something like to make sure you don't use the same iron. Wait, no, to make sure you don't use like the same nails, because like
Okay.
if you use the same, like if you're like like if you never mind.
Basically, you're saying that we should start with an unmagnetized nail, right? We shouldn't use the same nail because once we get the current flowing through it, it will become a little bit magnetic. So use the same type of nail. So use the same type of core. We should keep the core the same. I don't really see anything else in the chat, so I'm going to start to throw out some ideas here myself. We should keep the current the same. We should keep the current in the wire the same.
Jalen, stay focused, please. Like, put your phone down, put whatever it is doing that's distracting you away. Let's make
All
sure
right.
we can see your face.
So I'm going to give everyone another like 10 seconds to jot down these these notes for the variables and the control group, and we're just going to go straight into let's go ahead and do a hypothesis. So the purpose, we already talked about the purpose. You got 5 more seconds to write these things down. 5, 4, 3, 2, 1, and I'm scrolling down. The purpose is to test how number of turns of wire affects the strength. I'm going to just write over stuff here. Affects the strength of the electromagnet. I'm going to annotate that as E.M for electromagnet because it's hard to write on the screen. Each of you should now take 30 seconds to write down your own hypothesis. So what do you think is going to happen? If we change the number of turns in the wire, how will it affect the strength? Don't just say, I think it will affect the strength. And don't say, if we change the number of turns, the strength will decrease. You need to show if the relationship is going to go together or if the relationship is going to be opposite each other. So as I increase one, the other one increases. Or maybe as I decrease one, the other one decreases. Or maybe if I increase one, the other one will decrease.
Jason, are you there? Okay, good.
All right. The materials and the procedure, I'm actually going to skip over. They're very important parts. They are very important parts. We did do some work in procedure on our last performance task. But right now what I want to get into is actually showing you my setup and taking some data down. If you want to jot down your own notes for the procedure that I'm using, go ahead and do that. Let's see if this is working. Let me stop share again. Let me close this. All right, let's go. All right. And I'm going to share my screen. Give me a thumbs up if you see. Give me a thumbs up if you see the doc cam. Let's see. I do not see the doc cam. Switch camera. Nope. Stop sharing. All right, so I see it here in the visualizer. Let's go back in Zoom. Let's say screen share. Let's go to the visualizer, share. Yes? Give me a thumbs up if we see this now. Yes, okay. So what I have, and you can jot these notes down. What I have here are three electromagnetic cores that I have pre-made. The first one that you see here has 40 turns of wire. So we need to write down in our data. We need to make a quick table, a data table. And we need to write down that we have 40 turns. 40 turns is one of the magnets that I made. The next one that I made, this one here, has just about 60. I actually don't know the exact number, but this one has 60 turns. So we're going to write that down. This one has 60. And then the final one that I made, this one has a lot more. This one has 80 turns. So we've got 40, 60, and 80 turns. I have here already set up. I have a battery. And that battery is connected to 2 wires. And on the other end of those wires, I have clamps. Let me try to zoom out of this real quick. Let's zoom out a bit higher. Oh, maybe I can do this too. No? Okay. So I've got these 2 clamps. Now, one thing which I'm also supposed to do is try a control. So I have a nail here, which has no wires, no turns, or anything around it at all. I'm going to put my little dish of iron filings on my scale. Oops, let's try again. Let's start that, turn that on. All right, put my iron filings on the scale, and I'm going to set my scale to 0. I'm going to take my nail with 0 turns. I'm going to stick it in the iron filings, and let's see, what do we find? It doesn't pick anything up. and look at the reading here. It still says 0. If I picked anything up, that would actually become a negative number because I would be taking some weight away. I would be taking some of the mass off of the scale. So because I set it to 0, it would go to actually negative. So we're finding that our control group, which I'm writing here, control, can pick up 0 grams. Let's now go to the 40 turns. 40 turn wire. I'm connecting the 40 turn wire to my clamps. You may not be able to see it on the screen right now. There we go. And now I'm going to, and you may notice right now I have no current flowing. There's no current flowing, and if I stick it in there, it doesn't pick anything up. But if I get the current flowing, I have to change this a little bit. So, well, actually, can we all see there? That is actually picking up the iron filings. On the screen, you could see on the, that it says negative 2.4. So negative 2.4 is what it was able to pick up. So 2.40 turns was able to pick up 2.4 grams. Now, if we had more time, unfortunately, our science lessons are cut short a little bit. They're only 40 minutes. We would do multiple trials, right? We would do it maybe 3 or 4 times and take the average. But we want to just get through this right now. So let's move on to the 40 turn. This is now the electromagnet that has 40 turns on it. Connecting it to the leads. Ms. Roman, is there a break after this or another class?
There's another class. It's reading after this.
Reading, awesome. We're going to be on time for reading. Let's go ahead and test it out. So we see that the 40 turns also picks up, and it actually picks up a little bit more. This one was actually able to pick up 7 grams. Again, good scientists would do this more than once. We would actually do this maybe 4, 5, 6, as many times as we can, and we would take the average of it. So this one, we're going to write down on our notes that the 60 turns was able to pick up 2.8. Now let's go to the big one. This is the one that has 80 turns on it. Our scale is set to 0, so whatever we pick up will become a negative number. Let's get this done. Come on. All right, we got current flowing through the electromagnet. Trying to get a good connection. All right. Wow, this one, oops, I lost my connection there. This one feels pretty strong. This one picking up 4.1 grams. This is pretty messy too. So we're going to write down 4.1 grams into our data table. All right, scholars. So today we were able to test. We tested out how the number of turns. Hello, please mute yourself. We tested out the number of turns on an electromagnet and how it affects the strength of it. Let's just share out real quickly. Actually, show me on your hands. If we increase the number of turns, does the strength increase or decrease? We're increasing the turns. Did the strength increase or decrease? Point up or down. All right. So that should be decrease. So, Ms. Rahman, I think that it's 12:31. So I
Yes.
believe you have reading now.
Yep.
Okay, everybody. So go ahead, take your science packets and put them away. And there's no homework for, the only homework that I have for you is to read the text in your scholar packet, which tells you about magnetic force. Oh, I need to end this, and I need to give you a host, right, Ms. Ramon?
I think so, yes.
Yeah. Mhm.